Welcome to my YouTube channel. The first course that we are going to discuss on this channel is linear algebra, and today is our lecture number 1. So what is linear algebra? In geometry we can visualize things. In algebra we can generalize. The issue that we face in geometry is that we can't visualize things beyond 3D. And the issue that we face in algebra is visualization. So what do we do in linear algebra? That we merge visualization from geometry with generalization from algebra to tackle mathematical problems. The first topic of the course is system of linear equations. So first I take a linear equation. So in calculus we know that a linear equation is of the form y equal to mx plus c. And we also know that this equation always represents a straight line. And the graph of that straight line is fixed by these two numbers, this m and c. This m is known as the slope of the straight line and this c is known as the y-intercept. That is the point at which the line intersects y-axis. So if I take these three equations as y equal to 2x plus 2, y equal to x plus 2 and y equal to half x plus 2, then their graphs can be described as follows. In this first equation, the slope is 2, the intercept is 2, hence the graph of this equation intersects y-axis at the point 2 and it has slope 2. So as the slope increases, since the slope is a ratio of rise with run, hence the rise is higher than run, and hence the graph of this equation would be more closer to a vertical line. So the graph is given by this straight line for this equation. If we come to this equation as y equal to x plus 2, in this case once again the intercept is 1, 2, but the slope is 1. It is smaller than the slope of the first line, and hence it would be more closer to the horizontal axis as compared to this line. So it intersects the y-axis at this point, and as compared to the line of 2x plus 2, it is more closer to horizontal axis, as we can see in this graph. Similarly, if I move to this third equation, it is y equal to half x plus 2. Then in this case the intercept is 2. So once again I have this point of intersection with y-axis. The slope is 1/2, which is lesser than the slope of these two lines, and hence as compared to these two lines, this line would be more closer to horizontal axis, and hence the graph of this equation is almost given by this straight line. So if I consider a system of linear equations, so in a system we will have more than one equations, and as the first case I consider a 2D case where we can visualize objects quite easily. So a system of two equations in two unknowns can be expressed as follows: a1x plus b1y equal to c1 and a2x plus b2y equal to c2. And what are we interested in? We are interested in the solution of this linear system. So what do we mean by a solution of this linear system? A solution of this linear system means the values of the variables x and y such that if we substitute those values of x and y in both these equations, they are simultaneously satisfied. Hence, it can also be interpreted as a common point to both these equations. So as an example, if I consider these two equations in forming a system, x plus y equal to 1 minus x plus y equal to 1, as described in this case, a solution is a point in plane for which the equations in A, both the equations in A are simultaneously satisfied. And we can see that the point 0, 1, x is 0, y is 1. If we substitute the values of x and y simultaneously in both of these equations, they are satisfied. For example, x is 0, so 0 plus 1 is 1, and minus 0 plus 1 is once again 1. Hence, for this point in plane, which is basically 0, 1, both these equations are satisfied. And hence, by definition, we would say that this point 0, 1 is a solution of this linear system. It can also be, since both these equations are satisfied by this point, so this point can also be described as a common point to both these equations. So it can also be described as a common point. Geometrically, since it is a common point, hence this can also be interpreted as the point of intersection of the lines in plane described by the equations in a system. So if we consider once again the system in A, it can be written as x plus y equals 1. So it can be written as y equal to minus x plus 1. So this has intercept 1, slope minus 1. So intercept 1 means that it intersects y-axis at this point. It has slope minus 1. So the graph of this equation y equal to minus x plus 1 or x plus y equal to 1 is given by this straight line. Similarly, minus x plus y equals 1. So it can be written as y equal to x plus 1. The slope is 1, the intercept is 1, and hence I have this graph. And we know that the common point is 0, 1, which is also the point of intersection. So now what do? We generalize this concept to m equations in n unknowns. So a typical system of m equations in n unknowns can be expressed as a11x1 plus a12x2 plus and so on plus a1nxn equals b1, and the last equation can be written as am1x1 plus am2x2 plus and so on plus amnxn equals bm. And what are we interested in is given in A. We are interested in the solution of this linear system. And once again, a solution of this linear system would mean the values of the variables x1, x2 up to xn, so that if we substitute those values simultaneously in these equations, they are satisfied. Now, this using simple matrix algebra, this system can be represented as this. Here I have the coefficients matrix. Here I have a column matrix given by these variables x1 up to xn, and here I have a column matrix given by these constants on the right hand side. So if I call this matrix as A, this matrix as x, and this matrix as B, then I can interpret this system as Ax equals B, where A is an m cross n matrix, x is an n cross 1 matrix, B is an m cross 1 matrix. And what are we interested in? We are interested in the solution of the system described in B. And for this, once again, we go back to a 2D case. So if we consider a system in 2D, so we have the following possibilities. The system is given by a1x plus b1y plus a equals c1, a2x plus b2y equals c2. This is my system. And for appropriate choices of a1, b1, c1, a2, b2, c2, we have the following three possibilities. Number one, the lines represented by these two equations are parallel, like this. The lines represented by these two equations in this system intersect, but they intersect exactly at one point, this point. And the lines represented by these two equations in the system are overlapping lines. They lie over each other. Hence, I can describe these three cases as follows. That is, in this case, the lines in the system have no common point of intersection. We see that these are parallel lines and hence they will never intersect each other. In this case, they intersect each other but exactly at one point. In this case, they intersect each other and they intersect each other at infinitely many points. Hence, using this concept, we categorize our system given in that C, this system, in the following two categories. Number one, inconsistent systems, where the equations in the system have no common points or points of intersection. Is here, I have a system, the lines in the system have no point of intersection or common point, and the system represented by these two lines or these two equations will be termed as an inconsistent system, whereas the system given by these two cases will be termed as a consistent system. So, what is a consistent system? A consistent system is equations in the system have common points or points of intersection, as we have seen in cases B and C. Now, the problem is to generalize this concept and identify consistent and inconsistent systems. And if I have a consistent system, for example, if I go back to this case, here I have a consistent systems, but the difference between these two consistent systems is that here I have a unique point of intersection, whereas once again a consistent system, but there are infinitely many points of intersection. So, if we categorize our problem into consistent and inconsistent system, additionally we will have the following two things to identify. Number one, whether the system has unique or infinitely many solutions. We need to know that whether the system has a unique or infinitely many solutions. And number two, how do we obtain the exact form of these solutions? So these are the topics for our next lecture. Thanks for today.